Let's have a look at this question on one of the algebraic functions. If you remember them quite well, you will acknowledge that we are given a hyperbola in the sketch here. And a few things about the hyperbola: it will have two asymptotes. One is vertical, which has the form x equals to p, and the other is horizontal, y equals to q. These are the two equations for the asymptotes of the hyperbola. And we know also that actually these asymptotes intersect at the coordinate P and Q. The other thing that we know is that the hyperbola has the axis of symmetry. The one has a positive gradient and the other has a negative gradient. The axis of symmetry with the positive gradient, it is actually a gradient which is equal to 1, and it's a straight line of that form, and the one other will have the one in that form. I need you to keep this in mind because guess what? I can assure you, even without looking at the question thoroughly, by remembering these few facts about the hyperbola, you have basically built a strong foundation or base for you to answer the follow-up questions. Now, as you can see, there is a lovely piece of information given here that the asymptotes of h intersect at 1 and 2. In other words, this is the point 1 and 2. Just like that, we have values of p and q by just rewriting our equation in the form 1 over x minus 1 plus 2. Just like that, it becomes clear that p is a -1 and q is a +2. So there's no debate on this one. Simple, straightforward. Now, calculate the coordinates of the x-intercept. Again, we know the principle. You take note, this question here requires you to have answered that question. So for the x-intercept, we're going to make y to be 0, and I have x minus 1 plus 2. I will have -2 on the left, and I'll have 1 over x minus 1. And allow me to just write everything in this little block. Then I will have x minus 1 is equal to 1 over -2, which is just -1/2. Now, what has happened here? I'm using the lovely relationship between distance, speed, and time. So if you remember this triangle DST, it says speed is distance over time. But I know if I want to calculate time instead of speed, I just switch those around, and time is distance over speed. So I noticed that relationship with these three quantities here. Remember, x minus 1 is just a number on its own. So that is why I just switched around. I swapped the x minus 1 with the -2. And it becomes clear that x is -1/2 plus 1, which is 1/2. And if you look at the diagram, this makes sense because there is the x-intercept, there is the graph crossing the x-axis, and clearly this happens between 0, the origin, and the vertical asymptote 1. So the answer makes sense. It is always important to try and check if the answers you are getting do relate to the diagram. Now, I'm going to clear the screen here so that I can clearly answer. Well, I can clearly answer the third question with clarity. I don't want you to miss that. Now, remember, h of x is 1 over x minus 1 plus 2. If I asked you to calculate h of 3, you would simply substitute 3 in the place of x, right? Now, if they are defining a new function here in terms of h, you need to get a picture, a sense of how that function looks like, in contrast with the given function. So I'm going to substitute x plus 3 in the place of x from the given function, and I'll pick a different color for this. So if I want h of x plus 3, it means in the place of x, that x, I must put in x plus 3. I must put in x plus 3 and subtract 1. The plus 2 is there. So this will be x plus 2 plus another 2. So remember, this is what g of x is, which is defined in terms of h. Now, if I were to compare this function and that function, what has happened here? Well, I hope you'll agree with me that there is clearly a shift in this new function. Okay, and to find the coordinate of the x-intercept, most people don't see this visually, but what you would then need to do is to I propose rather, yeah, that you actually just go first principles and just make y 0. Why not? There's no harm in actually doing that. So I'm gonna do that. I'm gonna make y 0, and those of you who can do it visually, of course, that is excellent. All right, and I will have this over x plus 2. I'm just doing this so that everyone will understand what happened. Okay, that's over that. But what's going to happen here? I'm going to take 2 to the other side. So then I'll have minus half, and then I'll have minus 2. Okay, I had plus 2, remember? So I'm taking it to the other side, and I have that. Obviously, then this here is negative 3. Negative 3 over 2. No, it should be negative 5 over 2 because that's 2.5. Okay, so 2.5. Otherwise, this is just basic calculator work. I said 5 over 2, but I wrote 2 over 5. Okay, so let me fix that. At least I remember this. And that is, yeah, just like that, you are done with question 3 there. So let's take that as 1. Let's take that as 2. Let's take that as 3. The last question then answer is this one here that looks for the equation of the y-intercept of the equation of the axis of symmetry. I've already mentioned the 2. Clearly here they want us to find the equation of the line of symmetry with the positive gradient. So how we work that out? I know that the equation of the axis of symmetry always passes through the point of intersection of the 2 asymptotes. So this is the one with the positive gradient, and that is the one with the negative gradient, obviously not drawn to scale. Now, how do we solve this? Obviously, I have to substitute a point on the graph to find the unknown. So y is 2, x is 1, and that is plus t. It becomes clear that t has to be equal to 1. Easy marks, as you like. Now, if you look at this last question here, it's an inequality, and I would like us to rewrite it and see that they are actually asking us about our original function. So, excuse me, if I have 0 less than 1 over x minus 2, maybe let me just, sorry, I don't know where I get x minus 2. I have this, and I still put x minus 2, and I have that. If you notice, this is essentially saying 0 less than that, x minus 2 plus 2. Now, what is this? This thing on the right, again, that minus 2 has popped in. Okay, it's a 1, all right? This is actually our original function, h of x. That's actually h of x. Now, let's think about this. If I say a is less than or equals to b, it means b is bigger than or equals to a. All right, that's what it means. So this implies that. So I would rather than rewrite this thing and say, oh, actually this thing says h of x bigger than or equals to 0. Now, what does this mean in itself? It means you want parts of the graph that are above the x-axis. Now, here is the x-axis, and we can see the graph is above the x-axis on 2 regions. This is the first region, just up to the x-intercept, and take note, we will include the x-intercept in this case because there is greater or equals to, it's not strictly greater than, so we have to include the 0 of the graph as well. And clearly, it will be undefined at the asymptote, but it continues to be above x there. So our 2 answers will be as follows for number 3. We will say, well, for as long as x is less than or equal equals to the intercept, or x is bigger than p, that is the value of the asymptote actually, or x is, so clearly from the asymptote onwards, it is above the x-axis. And that sums up this entire question. I hope you have understood this. Put up comments, like, subscribe, and share with your fellow classmates. Thank you very much for watching.